Alright, in this video, we'll be talking about charges and electric field. Now first, charges are just like the building blocks of electricity. Here we said just like the cell is the fundamental unit of living things, charges can also be regarded as the basic or fundamental unit of electricity. Okay, in other words, we cannot talk about electricity without talking about charges. Charges are like the fundamentals or the fundamental units of electricity. Now, electric charge is a scalar quantity. That's to say, electric charge only has magnitude, all right? It does not have direction. Electric charge is a scalar quantity and its unit is coulombs. Do not forget the unit of charge is coulombs and it has its symbol to be Q, all right? So charges are measured in coulombs, or they have their unit to be coulombs, and then their symbol is Q. Now, electric charges are of two main types. We have the positive charges and the negative charges. The positive charges are carried by the proton, which are known as the positively charged particles, and then the negative charges are carried by the electrons, which are known as the negatively charged particles. All right, matter consists of the protons, neutrons, electrons, all right, subatomic particles. The positively charged particles are the protons, all right, and they carry positive charges. Negatively charged particles are the electrons and they carry negative charges. All right, we also have the neutron. The neutron are the neutrally charged particles. They are neither positive nor negative. Now, below here, we have the diagram for a positive charge and we have a negative charge. This is a positive charge, and these lines here describe the field around a positive charge. Whereas this one here, we have the field around a negative charge. Please take note of these diagrams. They are not the same. Here, the field around a positive charge behaves radially outward. You can see the lines of forces, all right? These lines, we call them lines of forces. They show the direction of the electric field, okay? The lines of forces are pointing outwards, all right, in different directions. So it says radially outward. There is a field around a positive charge, and then the field around a negative charge is radially inwards. All right, you can see it coming from different direction, and then the arrow is pointing inwards. Okay, so this is the field around a negative charge, whereas this is the field around a positive charge. Now we are going to talk about charging a body. All right, the process of charging a body. Now, charging a body simply refers to the process of making a body without charge. All right, the body without charge, as a neutral body, to become charged, that possess either a positive charge or a negative charge. That's what charging a body basically involves. Making a body without charge to now possess a charge. That's making a neutrally charged body to become either positively charged or negatively charged. Now, two main methods of charging a body are the charging by induction and then the charging by conduction. All right, we have charging by conduction and charging by induction. These are the two main methods of charging a body. Now, in charging by conduction, the two bodies, that's the charged and uncharged, are brought in contact with each other or rubbed vigorously over one another. All right, this sometimes is called charging by friction. Basically, in conduction, we have the two bodies. All right, that's the charged body and then the uncharged body, the one that wants to charge, which is the uncharged body. All right, we have the charged body, the one that possesses a charge already, and then the uncharged body. They are brought in contact with each other. Emphasis on the word contact. There must be contact in charging by conduction. All right, they are brought in contact with each other. All right, that's charging by conduction, or they are rubbed vigorously over one another. That's charging by friction. Now, this charging by conduction, sometimes it is divided into two. We have the charging by contact and then the charging by friction. All right, these contacts, they will just be brought close to each other. After a while, you see that there will be migration of electrons, all right, between the charged and uncharged body. The same thing happens in charging by friction. there'll be migration of electrons between the charged and uncharged body. Look at what we have here. This example, this illustration here says we have charged A, all right, body A rather. We have body A. Now body A before contact, and then B before contact. This is after contact. Now let's look at body A here. Body A is simply a positively charged particle. Why is it positively charged particle? Because we have excess positive charges. All right. The fact that they wrote only positive charges here without writing negative charge simply means the positive charges are in excess. That's why they just showed us only positive. Okay. So whenever you see a situation like this where it's only positive that you have here, all right, or they only show you only positive charges here, it simply means the positive charges are in excess. If it's only negative they draw here, it simply means the negative charges are in excess. That's why they show you only the negative charge, or they indicate only the negative charges. All right. It does not mean, for instance, in this case, this body here has only positive charges. No, that's not what it means. It simply means the positive charges in this body are in excess. That's why they are showing us, or they indicated only positive charges here. So body A, because it has excess positive charges, we'll say is a positively charged particle. Now look at body B. Body B here has 1, 2, 3, 4, 5, 6, 7, 8. Counting the negative charges, we have 8 negative charges. Now, for the positive charges, we have 1, 2, 3, 4, 5, 6, 7, 8. All right, the same 8 positive charges. That's to say the number of negative charges and the number of positive charges are the same. So say this is neutral. This is how we identify a neutral body. All right. So body B is neutral, and then body A is positively charged because it has excess positive charges. All right. So before contact, you can see positively charged particle, neutral particle. They are now brought in contact with each other. Now during contact, there is migration of negative charges into body A. All right. There is migration of negative charges into body A. Please take notes. Take note of this. Very, very important. During the migration of charges, only electrons move. That's only negatively charged particles move. All right. The positively charged particles do not move. So whenever we have charging by contact or charging by conduction or even charging by induction, all right, it is the negative charges that will move. The positive charges do not move. So here, look at what we have. We have during contact, the negative charges will migrate. Okay, they will migrate into body A. Why are they migrating into body A? Because body A here has more positive charges, and then because of that, it's going to attract the negative charges here. The law of electrostatics. All right, unlike charges attract positive and negative. We have more positive here, so it's going to attract the negative we have here. All right, more like compelling them to come over. Okay, so the negative charges here will be attracted into body A, and then this is what we have here after contact. You can see that the negative charges in B now have moved to body A. Okay, now this is what body A now looks like, and then this is body B. Now because the negative charges have been attracted into body A, body B now becomes positively charged. So you can see that initially it was A that was positively charged. Now after charging, all right, after charging, that's after the whole process, body B now becomes positively charged. That's to say, a very important point you should take from this is that if we have a positively charged particle, and then we are, sorry, a positively charged body, and then we are using it to charge a neutral body. If you have a positively charged body being used to charge a neutral body, the neutral body at the end of the day is going to become positively charged. All right, very, very important. A positively charged body used to charge a neutral body. The neutral body, that's the one which does not possess a charge, will become positively charged at the end of the day. If you have a negatively charged body being used to charge a neutral body, the neutral body at the end of the day will now become negatively charged. All right, so positive charge produces positively charged body. Negatively charged body will also give us negatively charged body. That is it. All right, other examples of charging by contact, we have ebonite rod rubbed with 4 becomes negatively charged. All right, glass rod rubbed with silk becomes positively charged. Now a strip of polythene rubbed with a dry woolen cloth becomes negatively charged. Cellulose acetate rubbed with cotton material becomes positively charged. These are some common examples of charging by conduction. All right, and these have already been proven experimentally to be correct. Okay, so these ones have already been carried out experimentally and they've been proven to have these charges as indicated here. Now the next one we'll be talking about is charging by induction. Now in charging by induction, the two bodies, that's the charged and uncharged body, are only brought close to each other without contact. In charging by induction, there is no contact. The two bodies are only brought close to each other without contact. So looking at what we have here, we have neutral body, all right, and then here we have, this is a negatively charged body, all right. We have a negatively charged body, and this is our neutral body, all right. Now don't forget, this is your neutral body, so that means this is going to be our neutral body. So we have our charged body, all right. Remember, in charging by induction, there is no contact. The two bodies are only brought close to each other. Neutral body, all right, and then we now have our negatively charged body being brought close to the neutral body. Now when it is brought close to the neutral body, what happens? All right, our law of electrostatics will take place. Now the neutral body, don't forget, will contain both positive and negative charges as shown here. You can see we have, let's count the positive charges: 1, 2, 3, 4, 5, 6. Here we have 1, 2, 3, 4, 5, 6. So that's what makes it a neutral body. All right, so we have negatively charged body being brought close to the neutral body. Don't forget, in charging by conduction, no contact is involved. So as we bring them close to each other, the negative charges here will attract the positive charges and repel the negative charges. So that's why you see that the positive charges will now come and align themselves in front, and then the negative charges will go to the back here. All right, so we have negatively charged body attracting the positively charged particles. All right, attracting the positively charged particles and repelling the negatively charged particles. Negatively charged body, why is it negatively charged? We have only negative charges indicated here. That's to say we have excess of negative charges here. So it's going to attract the positive charges and repel the negative charges. So this is now what it's going to look like. All right, so this is step 2. So look at what we have here: neutral sphere at first. Now number 2 here, it says approaching the sphere with a negative rod. Okay, this is a negative rod. Separates the charges in the sphere. That's to say the positive charges will be attracted to the front and then the negative charges will be repelled. Law of electrostatics will occur here. Now number 3 here says with this rod, that's the negatively charged rod, nearby, the negative end may be discharged. How is it discharged? We do what we call earthing. All right, see the symbol here for earthing. Say electrons flow to the earth via the wire. All right, so we connect the sphere to the earth using a conductor, using a wire. All right, so with the rod still there, with this negatively charged rod still there, the positive charges are attracted, are brought close, negative charges are repelled, and they are meant to move to the back. All right, as this occurs, all right, or after this occurs, or during this process, we now earth the sphere. All right, we conduct it or connect it to the ground. By connecting it to the ground, these negative charges will now have an alternative route to move out of this sphere, because this negative body here, the negatively charged body here, or the negative rod, is pushing them, all right, or repelling them away. And connecting this system now to the ground will now provide an alternative route for these negative charges to now move out. All right, so the negative charges now will move out to the ground. All right, why would they move out? Because look at the negative rod repelling them, that's pushing them away. All right, as it's pushing them away, if you now provide an alternative route here, right, which is like the earthing material, the negative charges will be forced to move out, so they will move down to the ground. All right, and by the time they move down to the ground, we'll now be left with only positive charges in this sphere. All right, now after they've moved out, we don't immediately remove the rod first. Please take note, very, very important. After the negative charges have moved out, you'll be left with only positive charges inside this sphere. Yes, but you don't remove your rod first immediately. All right, what you're supposed to do now is, after these negative charges have moved out, you disconnect this earthing material so that they cannot move back again. All right, because if you remove your rod first and this earthy material is there, the negative charges will move back in because there will be nothing to repel them. There's nothing pushing them away. Remember, it is this rod that is pushing them out. All right, so if you remove this negative rod first without removing the earthy material, the negative charges will move back in. So that's why it is said, or you must remove the earthy material first. All right, after the negative charges have all moved out, remove the earthy material first. All right, so that the negative charges cannot move back in. All right, after removing the earthy material, you now remove the rod. As you remove the rod, the positive charges will now arrange themselves as we have here. Okay, so you can see this sphere, which was neutral initially, is now positively charged. It says with the rod moved away, the positive charges distribute evenly. So they will not distribute themselves evenly, all right, on the sphere. But don't forget, you remove earthy material first before removing the rod. Now, in charging by induction, one key thing I need you to take here is that look at this case. We are using a negatively charged body to charge this neutral body. At the end of the day, the neutral body becomes positively charged. So in charging by induction, if you use negatively charged body, your neutral body becomes positively charged. If you use positively charged body to charge the neutral body becomes negatively charged. So in charging by induction, negative will give you positive, positive will give you negative. All right, and then for charging by conduction, positive gives you positive, negative will give you negative. In induction, negative gives positive, positive gives negative. All right, so that is how we charge a body, or the two main methods of charging a body.